In this video, we're going to talk about how to find vertical and horizontal asymptotes of rational functions. Our rational function is x to the 3 plus 4x to the 2 plus 4x divided by x squared minus x. Now, first of all, let's talk about horizontal asymptotes. Now, there are three cases that you want to be aware of when you're looking for a horizontal asymptote. Either you're going to have the same degree on top and bottom of your fraction, in which case it's going to be the ratio of the leading coefficients, or you may have a higher degree on top, at which case you're going to have no horizontal asymptote. And the third and final case is that you would have a higher degree in the denominator, at which case y equals 0 would be your horizontal asymptote. Now, you definitely need to have those memorized. Those wouldn't probably be provided for you on a test, but you can still interpret them once you have them memorized. It's pretty easy. Just looking at our problem right here, the degree on top is a 3. That's just the highest exponent. The highest exponent or degree on bottom is a 2. So we definitely have a case where we have a higher degree on top, which means that we have no horizontal asymptote. So we can just say none. Now when it comes to the vertical asymptote, we'll have a little bit more work to do for this example. The first thing you always want to do is you always want to take the preliminary step of factoring out the top and the bottom as much as you can. So what I'm going to do is I'm just going to bring our problem right down here. I'm going to go ahead and factor out an x on top and bottom. So taking an x out on top is going to leave us with x squared plus 4x plus 4. And we're going to do the exact same thing in the denominator. So you always want to factor as much as you can wherever you can. In the denominator, we're also going to take out an x, leaving us with x minus 1. And so now notice what's happened. We have an x on top and bottom, which we can cross out. And what that is we would set this normally the denominator equal to 0, and then we would say each of those factors equal to 0 and say, those are both our horizontal asymptotes. But the problem is, if something does cancel on top and bottom, what that represents is just a hole in the graph. So in this case, the x factor canceling on top and bottom means we don't actually have a vertical asymptote at x equals 0, we just have a hole in the graph. So it's still an undefined value, but just not something that blows up to infinity like an asymptote. Now we can factor a little bit more in the numerator, so we might as well do it just to be safe. X squared plus 4x plus 4 factors into x plus 2 multiplied by x plus 2. And that confirms the fact that there's nothing else we can really cancel out at this point on top and bottom. So whatever you have left over after you've canceled everything out, take your factors in your denominator and set them equal to 0. So we'll say x minus 1 equals 0, and of course add the 1 across, and we get x equals 1. So x equals 1 is going to be the equation of our vertical asymptote, and the only vertical asymptote for this particular rational function.